There we go. Okay, so inverse functions today. The first thing I want to do is talk about how do we view functions. And originally we explained functions like it was a machine. And we all know I can't draw, so just go with me on this. Right? Here's the little conveyor belt coming in. Here's the little conveyor belt going out. And inside was an equation that we had to do. So maybe we were taking whatever we started with and we were multiplying it by 3 and then adding 10 onto it. And a number would go in and something else would come out. If I were to put an 8 in, 8 times 3 was 24, plus 10 became 34, and 34 would come out. I could repeat this with different numbers coming in, and ultimately I could make a table that showed if 3 went in, if 5 went in, if 8 went in, what came out. So 8, we said it was 34. At 5 would be 15, so 25. At 3, it would be 19. That was it going in and coming out. What happens if I try and take the inverse of a plus 10? I'm undoing that. So undoing a plus 10 means I'm going to minus 10, right? I'm going to work it backwards. That's what the inverse of a function is. Now, instead of my machine flowing forwards, it's going to flow backwards. Because now I know I got a 34 out. I know what the machine does, but I don't know where it started. And I need to work backwards to figure out where it started. So now my machine is on reverse, and my 25 went backwards. Well, I said that originally I was plusing 10. I was multiplying by 3 and adding 10. If I were to work that backwards, what do I have to do first? Minus 10. And then what do I have to do? And then I'm going to have to divide by 3. So that if I minus 10 would be 15, divided by 3 comes out 5. Does that show me the right thing that I'm seeing over here? My output's 25 and I originally started with 5. Good. That's the concept of inverse function. The easy way to do it if I have a table. Goodness, let's see if I have a table. If this was the table they gave me, and they said, what's the inverse function of this? Switch them. What's up?
Is the first number a 7 or a 9?
A 7. It's just blending in with my y. It's a good question. I'm going to jump back to my previous screen, but I will come back to this. When I worked it backwards, my previous answer all of a sudden became my input to the machine, which is why I switched them, right? What was my output just became my input. Thus, what letter do we use for inputs? X's. Really, all I did was I switched my X's and my Y's. Whether they give it to me in a table, I don't know if you guys remember this. Do you guys remember these displays? Input, output groupings? And this meant that my input, my 3 was paired with my 9, my 4 was paired with my 2, my 7 was paired with my 8 and my 3, and my 10 was paired with my 4. If I'm going to find the inverse of this, again, all I'm doing is switching, and I'm going to be writing that now my 9 is paired with my 3, my 2 is paired with my 4, my 8 is paired with my 7, my 3 is paired with my 7, and my 4 is paired with my 10. So this original function becomes that inverse. This will be the first few questions on your homework. This is one of the questions on the test. How do I find the inverse of a function? All you're doing is switching the numbers in your x's and the numbers in your y's, reversing their order. I'm going to give you a minute to finish, or probably hopefully less than a minute to finish writing this down. There's one more piece of what we're going to learn, and then I'm just going to let you get to your work. When I have an equation, they didn't give me a table, they didn't give me that input-output grouping or mapping, they gave me an equation. And they said, find the inverse. Okay, let's be real. Are they going to give you y equals 5x minus 23 in this book? No. That was just rude. They actually write it as f of x equals 5x minus 23, right? Don't erase yet. Because the reality is the first thing you want to do is change that f of x into a y. They mean the same thing. F of x means the function, the output of the function, and y is the output of your function, right? So you can just change that. Because if you recall on the previous screen, we talked about all we're really doing is changing our x's and our y's. So guess what the first thing you're going to do after this is? Change your x and your y, swap them. This y becomes an x and that x becomes a y, and everything else stays the same. And then they're going to say, graph this. What's the form we needed in to graph it? Y equals mx plus b, which means that y right here needs to be by itself. How do we get y by itself? We do the inverse of every number that's with it, right? So if I have a minus 23, I will be adding 23. This This is my favorite part because everybody goes, well, x plus, no, they're still separate. X plus 23 is x plus 23. And now I need to get rid of my y. If it's being multiplied, inverse is divide. And I end up with my y by itself. You can leave this as this whole thing, x plus 23 divided by 5. Or you can split that 5 up into each term and make it x over 5, which is really just 1/5 x, plus 23 over 5. And if 5 doesn't go in evenly, by all means, just leave it as a fraction, 23 over 5. And you are done. Now this is in y equals mx plus b. And you could graph this. It's not an easy thing to graph because of that fractional starting point, but it is graphable. If you struggle with graphing it at this point, make a table. Plug in numbers, see where everything comes out. And you should be able to do it from there. Any questions? No? Excellent. I'm going to let you guys get to work.